Zigbee explained in 10 minutes. A Zigbee module is a small, low-power radio frequency (RF) communication module that utilizes the Zigbee protocol, designed for wireless communication in personal area networks (PANs). Zigbee is based on the IEEE 802.15.4 standard and is popular for Internet of Things (IoT) applications due to its low power consumption, reliable communication, and support for mesh networking, allowing devices to communicate over long distances by passing data through intermediate devices. The key features of Zigbee that make it suitable for IoT and wireless sensor networks include low power consumption, designed for energy efficiency, enabling devices to operate on small batteries for months or even years. Sleep mode support helps further conserve power, making it ideal for battery-operated devices. Mesh networking supports a mesh topology where each device or node can relay data to other nodes. Allows for communication over extended distances as data can hop from one device to another until it reaches its destination. Scalability supports large networks with up to 65,000 devices, allowing scalability for extensive applications like smart cities or large industrial networks. Can integrate with other devices seamlessly, making it flexible for expanding systems. Reliability and robustness. Self-healing network. If one node fails, the network automatically reroutes communication through alternative nodes. Designed for environments with potential interference, making it reliable in settings like industrial sites. Low data rate. Data rate is typically capped at 250 kbps, ideal for applications that require periodic or small data transmissions, such as sensor readings. Secure communication. Incorporates security features like 128-bit AES encryption, ensuring data integrity and secure communication within the network. Interoperability. Standardized protocol that promotes interoperability between different manufacturers' devices, enabling various Zigbee-compatible devices to work together in the same network. Cost-effective. Low-cost hardware and simple network setup make it a cost-effective choice for large-scale deployments. Flexible device roles. Supports various roles for devices. Coordinator, one per network, responsible for starting and managing the network. Router, for routing data across nodes and expanding network range. In-device, communicates only with its parent router or coordinator, helping conserve power. Range, typical indoor range up to 100 meters, 328 feet, and outdoor range up to 300 meters, 984 feet. Extended range possible through mesh networking, where nodes act as relays. These features make Zigbee an attractive solution for wireless, low power, and low data rate applications like home automation, smart meters, and sensor networks in IoT. Zigbee modules are widely used across industries due to their low power, reliability, and support for mesh networking. Here are some key applications of Zigbee modules. 1. Home automation. Smart lighting. Enables remote control of lights, automated scheduling, and dimming features. HVAC systems. Allows for temperature monitoring and remote control of heating, ventilation, and air conditioning systems. Smart plugs and switches. Control power to appliances, reducing energy consumption. Security systems. Support sensors for doors, windows, motion detectors, and smart locks to enhance home security. 2. Industrial automation. Machinery monitoring. Collects data on machine status, performance, and potential issues, helping in predictive maintenance. Remote equipment control. Allows for remote start, stop, and adjustment of machinery in hard-to-reach or hazardous areas. Industrial sensors. Monitors environmental parameters, temperature, pressure, humidity, to ensure safe working conditions. Process control. Enables real-time monitoring and control of industrial processes for improved efficiency and safety. 3. Smart energy management. Smart meters. Monitors electricity, water, and gas usage, enabling real-time reporting and remote billing. Load control. Helps manage electricity loads during peak times, reducing grid stress. Solar and wind power management. Monitors and controls energy produced by renewable sources for more efficient use. Electric vehicle charging. Manages and monitors EV charging stations and usage patterns. 4. Healthcare and medical devices. Patient monitoring. Monitors vital signs and conditions remotely for patients, enabling efficient, Real-time health management. Wearable health devices tracks health metrics such as heart rate, blood pressure, and activity levels. Elderly care facilitates emergency alert systems, fall detection, and location tracking to ensure elderly safety. Medical device control allows for remote adjustment and monitoring of medical equipment. 5. Agriculture and farming. Environmental monitoring monitors soil moisture, temperature, and humidity to optimize crop growth. Irrigation systems automates irrigation based on real-time data, conserving water and improving crop yield. Livestock monitoring tracks the location and health of livestock, aiding in efficient farm management. Pest and disease control uses sensors to monitor conditions favorable to pests and diseases, enabling timely intervention. 6. Retail and commercial applications. Asset tracking monitors inventory and asset locations in warehouses or stores, reducing loss and improving efficiency. Indoor location services enables navigation and asset location tracking within large retail spaces or shopping malls. Point-of-sale systems connects POS terminals wirelessly, making checkout counters more flexible. Customer behavior tracking collects data on customer movement and preferences to improve store layouts and promotions. 7. Smart cities. Street lighting control enables smart control and dimming of street lights based on time and traffic flow, reducing energy costs. Traffic management monitors traffic and adjusts signals to improve flow and reduce congestion. Waste management monitors waste levels and bins to optimize collection routes and schedules. Public safety and surveillance supports smart sensors for pollution monitoring, noise levels, and environmental hazards. 8. Environmental monitoring. Air quality monitoring monitors pollutants and air quality in urban and industrial areas. Weather stations collects data on temperature, humidity, wind speed, and rainfall for climate and weather predictions. Water quality monitoring measures parameters like pH, turbidity, and temperature in water bodies. 9. Building automation. Access control enables secure entry and exit management for buildings with smart locks and access points. Lighting and climate control optimizes lighting, heating, and cooling in commercial buildings for energy efficiency. Fire and safety alarms monitors for smoke, gas leaks, or fire, and alerts emergency systems immediately. 10. Automotive applications. Vehicle tracking and monitoring monitors location, speed, and conditions for fleet management. Tire pressure monitoring tracks tire pressure in real time to improve safety and performance. In-vehicle connectivity enables wireless communication between devices within a vehicle, supporting IoT-enabled smart features. These applications highlight the flexibility of Zigbee modules in a wide range of sectors, particularly where low power, reliability, and a secure mesh network are crucial. There are several popular Zigbee modules available, each offering unique features tailored to different types of IoT applications. Here are some of the most widely used. 1. XB Series by DG International. Models: XB Zigbee 3.0, XB-S2C, XB Pro. Features: known for ease of use, making it popular for prototyping and small to medium-scale IoT applications. Supports both point-to-multipoint and mesh networking. Plug-and-play functionality, with options for both standard and extended range, Pro versions. Offers data encryption for secure communication and low latency for real-time data transmission. Applications: home automation, industrial monitoring, smart agriculture, and wearable devices. 2. DG Zigbee modules. Models: DG XB3, DG XBSX. Features: advanced power-saving features, making them ideal for battery-operated devices. Zigbee 3.0 compliant, offering improved interoperability across different Zigbee-certified devices. Small form factor with integrated RF and antenna options. Provides MicroPython programming capability, enabling custom code and scripts directly on the module. Applications: smart homes, asset tracking, building automation, and healthcare monitoring. 3. Ember Zigbee modules by Silicon Labs. Models: EM35X series, EM358X series. Features: high-performance modules designed for commercial and industrial applications. Offer long battery life, low power operation, and extensive RF range. Comprehensive development tools and libraries for easy integration, often used for large-scale applications due to their reliability and robust features. Applications: smart metering, security systems, large industrial IoT networks, and building automation. 4. Texas Instruments Zigbee modules. Models: CC2530, CC2538, CC2652R. Features: highly customizable, with support for Zigbee as well as other protocols like Thread and Bluetooth in multi-standard configurations. High data throughput and energy-efficient design. Integrated with Zigbee development kits for easy application design and testing. Applications: smart lighting, energy management, asset tracking, and smart appliances. 5. Telegesis Zigbee modules. Models: ETRX357, ETRX3 series. Features: compact modules with options for external or built-in antennas. Easy to use at command interface, simplifying integration with microcontrollers. Pre-certified Zigbee modules, saving time and regulatory compliance. Widely used in Europe for smart home and energy management solutions. Applications: smart metering, home automation, HVAC control, and healthcare applications. 6. Genix/NXP Zigbee modules. Models: JN5168, JN5169. Features: focused on low power consumption, ideal for battery-powered devices. Supports multiple network topologies, mesh, star, point-to-point. Integrated processor and transceiver, simplifying hardware design. Applications: sensor networks, remote monitoring, smart agriculture, and environmental monitoring. 7. MIUI/Zigbee modules by Microchip. Models: MRF24J40, RN4020, Bluetooth plus Zigbee hybrid. Features: flexible modules that can operate with both Zigbee and proprietary MIUI protocols. Designed for low-power applications with secure wireless communication. Easily integrates with Microchip microcontrollers for end-to-end solution development. Applications: wireless sensor networks, home automation, and healthcare systems. 8. Atmel Microchip Zigbee modules. Models: ATZB-RF233, ATZB-RF212B. Features: known for low power operation and compact design. Compatible with Atmel's extensive development ecosystem for streamlined application development. Widely used for projects requiring strict low power requirements. Applications: consumer electronics, wearables, asset tracking, and smart home devices. 9. SmartThings Zigbee modules, Samsung. Models: used in SmartThings Hub and various smart home devices. Features: designed specifically for smart home applications, ensuring smooth integration with other SmartThings compatible products. Supports multi-protocol capabilities for seamless operation with different devices. Provides an end-to-end solution for smart home automation with high interoperability. Applications: smart home hubs, lighting, security, and appliance control. These Zigbee modules provide a range of solutions from consumer smart home devices to industrial IoT applications, catering to different power, range, and scalability needs across IoT ecosystems. Zigbee has several advantages that make it a preferred choice for wireless communication in IoT applications, especially where low power and reliable networking are essential. Here are the primary advantages. 1. Low power consumption. Zigbee is designed to consume minimal power, enabling long battery life in devices, often lasting months or even years. It supports sleep modes and low duty cycles, making it ideal for applications where devices are idle most of the time but need to transmit data periodically. 2. Mesh networking support. Zigbee supports a mesh network topology, where each device can relay data to others, creating a robust, self-healing network. This mesh capability extends the communication range by allowing data to hop between nodes, making it suitable for large-scale networks and areas with obstacles. 3. Scalability. Zigbee networks can support up to 65,000 devices, making it highly scalable for applications like smart cities and industrial automation where numerous sensors and devices are needed. 4. Low data rate for efficiency. Zigbee operates at a data rate of up to 250 kbps, which is sufficient for applications that only require intermittent, low-bandwidth communication, like sensor readings. The low data rate contributes to lower power consumption, further extending battery life. 5. Reliability and robustness. The mesh network structure enables Zigbee devices to reroute data if a node fails, making the network highly resilient. It operates on the 2.4 GHz ISM band and also supports regional sub-1 GHz bands, which helps reduce interference and ensures stable communication. 6. Cost-effective. Zigbee modules and devices are generally low cost, making it an affordable choice for large-scale deployments. The simplicity of the protocol and the hardware requirements reduce both initial costs and ongoing maintenance expenses. 7. Secure communication. Zigbee uses 128-bit AES encryption to ensure secure data transmission, protecting against unauthorized access and data breaches. It also supports device authentication, which enhances security, especially in applications that handle sensitive information. 8. Interoperability. Zigbee is an open standard, meaning devices from different manufacturers can often communicate with each other if they are Zigbee certified. This interoperability allows easy integration of multiple devices into a single network, beneficial in multi-vendor environments. 9. Global standard with regulatory compliance. Zigbee operates on standardized frequency bands globally, making it compatible with regional regulatory requirements. This allows Zigbee devices to be deployed internationally without significant modifications, making it an excellent choice for global IoT solutions. 10. Flexible device roles. Zigbee networks include 3 types of devices: coordinators, routers, and end devices, offering flexibility in network design. Coordinator initiates and manages the network. Router extends the range by routing data between devices. End device consumes minimal power and communicates only with its parent router or coordinator. This structure allows developers to design efficient networks based on specific needs and power requirements. 11. Wide range with minimal infrastructure. While individual devices have a range of around 100 meters indoors and up to 300 meters outdoors, the mesh topology allows Zigbee networks to cover much larger areas without additional infrastructure. This is especially advantageous for applications like industrial monitoring and agricultural IoT, where extensive coverage is needed. 12. Simple network setup and maintenance. Zigbee networks are straightforward to set up and manage, with the protocol providing automated network formation, routing, and healing. This ease of use reduces the need for complex network management and maintenance, making Zigbee suitable for DIY and professional installations. These advantages make Zigbee ideal for a range of applications, from smart homes and industrial automation to smart energy management and healthcare monitoring, particularly in environments where low power and reliable, scalable networking are essential. With Zigbee's efficiency in low power, low bandwidth, and mesh networks, it remains a favored technology in the IoT space for a variety of industrial, home, and smart grid applications.